Alright, there we go. Everything is stripped. Got pretty much everything I'm going to use here. This metal box and the output transformer, little output transformer, and this power transformer. It's a big guy. And there's everything we didn't keep. Kind of old circuit board style construction. Right, so the next step is to figure out the spacing where everything's going to go in here, and then we'll do the circuit board layout. Alright, I am now to the point where I can start laying out my, my circuit components on a custom circuit board. So we know what the chassis looks like, and approximately where all of the parts are going to go. The off-board parts are going to sit in the chassis. So just to walk through that, the preamp tubes will sit here. I'm going to use these existing punched out holes to house the preamp tube. So we'll have the pentode here, probably the second stage triode here, and then here we'll have the phase inverter. And then what I'm going to do is I'm going to use a knockout punch to make 3/4 inch diameter holes for the 6P 1P power tubes over here on this side of the board, or on this side of the chassis. The output transformer will sit here and then get routed to the output jack for the speakers, which will be there. So that being said, this turret board, this is just a blank board with a bunch of holes drilled in it, and we can push in turrets wherever we want or wherever we need them to be. And so this will sit on standoffs probably somewhere around there. It's pretty tight in here, but we can make it work, no problem. So we have a lot of space on this side. Maybe our filament rectifier will go over there somewhere. So those are the actual signal components. The power components, most of them will sit over here. This is where the power transformer cutout is. I'll have 2 CAN capacitors here, and those will have each 2 16 microfarad capacitors. And that actually saves me quite a bit of space because I don't have to put discrete axial components on the board, which are actually quite large in diameter typically for tube amp voltages. So it saves me all that space on the board for other parts, you know, filament rectifiers or probably the bias supply. There is, I'm going to reuse this rectifier board. So this is the one that originally came out. I'm going to desolder all these old diodes, and that just sits right here. And that's conveniently located, and it's kind of using this Z direction to save a little bit of space. This will be my main high voltage rectifier. And then I think I can also pull off or I can route the heater wires through this board. So I have to kind of be a little bit careful. All of the controls will be on this panel. This is the only panel that I'll be able to access when it's in the cabinet. So the IEC socket, the main power input, is going to be over here. And then I'm also going to have to put a fuse somewhere over here, just a mains fuse. And then I want a power toggle switch, a power on toggle switch over here somewhere, and then an indicator lamp. So I'm gonna lose maybe not half, but maybe a third of this panel height just for the power components. And that will sit over here. You can kind of see it lines up with maybe the edge of the circuit board. And then I have the rest of the 2/3 to put the control pots for the amp. So all the potentiometers maybe from, right about here to the end, and then also the input jack. So we have 5 pots that we need. We have the master volume, we have the depth and the frequency of the tremolo, and then we have tone and the gain for the preamp stage. And we have input. So I have to fit all of those in this space, and then make sure to isolate everything, the power stage over here. Okay, so that being said, that gives you an idea of where everything's going to sit in here. It's a good idea to do this before you start laying out parts, where the parts are going to go on the circuit board itself. That's just so you know, if you have to run a wire off of a turret here, for your off-board wiring, you know that you're going to be fairly close. You want to make the wire runs as short as possible. So you want to be close to this tube, if this is the cap that goes into the phase inverter stage or something. So it's a good idea to keep in mind where all of these passive components sit relative to your tubes or other power supply components. So the way I like to do this is typically you start with the lower voltage, the high impedance, lower voltage, low signal lines on this side of the board, just because the input pentode is going to be right here. And then the input jack is going to be right here. So you start with your low signal lines, and then you work this way, eventually to your power to bias supply, and then the master volume will be over here somewhere. So if you look at the schematic, it's kind of working in the opposite direction. So remember we said we're starting with low signal lines over here. Well, that's the input, and then we work this direction. And so we'll start populating the board and laying out the components, working that way to the higher signal components. Yeah. All right, well, I'll sit down with a piece of paper and I'll start laying this out. All right, so here's a first draft layout. You can see it's quite messy. This is oftentimes how they look when I just first finish drawing them. A lot of erasing and redrawing things, and a lot of probably illegible labels here. But to break this up, we have the first two stages. So this is the first pentode and then the second triode stage. Then we have the phase inverter, which is pretty common. The way that these are laid out, you have these like triangular plate resistors and then plate capacitors. So then you have the LFO stage. This is the oscillator that controls that generates the tremolo signal. So the problem is this uses the second triode tube, which is in the middle, right? So if I draw the tube layout, this section, this phase inverter tube is here, and then the LFO tube is here. So actually what I want is I want to eventually, when I redraw this for the second round, I want to move this LFO stage between this stage and this stage, just because physically the tubes are located in such a way that it would be advantageous to do that. Just the wire runs don't have to cross one another. You don't get any potential cross-coupling, especially when you're dealing with low frequency oscillations. I mean, the currents aren't massive here, but the voltage swings can get on maybe some of the lower signal lines, especially if you're chopping things down with voltage dividers. So yeah, second round I'm going to move this LF over here. And then this is also a little bit messy, so possibly redrawing that just to look a little bit nicer. The third one, the power tube, these are the current sensing resistors on the cathodes. These I don't actually think will end up being on the board. I've drawn them here, but usually it's a lot easier, instead of running wires off the board and then running a wire to ground. A lot of times you can just get away with soldering these directly onto the sockets, and the sockets usually have little ground rings that you can solder these to. So I think that's probably the best way. Sometimes you get a little bit of noise if the ground isn't great to the chassis, but it should be good enough for what we want. So these probably won't be on here. This is the filament rectifier, full wave rectifier, dropping resistor that's in series with the filament, just because this probably won't be perfectly 6 volts. Actually, I know it won't, because I think this is a 12 volt rectifier. And then the filter capacitor, which will be off the board. Let's see here. So from there, let's see. From there we have this is the bias supply. So this is a half wave rectifier that comes off of the AC high voltage tap. And then that goes into a series of filtering capacitors, and then a pot, which will allow me to control the voltage. The pot will be mounted off of the board, but it will be like a 10K ohm trim pot, panel mounted trim pot. So that will be mounted onto the chassis somewhere, and then some kind of like lower limit resistor here. Yeah, this will be over to the left-hand side, just because what comes in here is basically the filament voltages, so you want to keep those as short and away from just about everything else that you can, because the current running through here is going to be pretty massive. Yeah, so I'll end up redrawing this, making it a little bit cleaner, maybe trying to redraw this LFO stage. Like I said, moving it back over between these two stages, just because of the way the tubes are laid out, removing these, and then moving this over to the left-hand side. Everything fits. So this is the width, this is the number of turrets that we have on that board that I'm using. So everything fits. That's pretty nice. I thought for sure I would have some issues here, but it looks good. So redraw, and then maybe we can actually start putting turrets in that board. And doing the fab on the chassis. All right, So I'm to the stage on this build where I am just checking where everything sits on the chassis. I'm making sure that everything will fit, that nothing will interfere with other parts inside the amp. So I can kind of get ready to drill these holes and put their final locations in place. That's going to have to be cut, that kind of squarish rectangular cutout with a Dremel and a cutoff wheel, which is what I typically do. It works pretty well. Found these knobs in the part bin. This is from an old Magnetone restoration. These Davies 1500s, they look pretty cool. So I think I'll end up using those. They're brand new. Just laying everything out, making sure it doesn't bump into the filter caps, and I have enough space there to wire everything up. You can see I put the rectifier board in there, just mock fit. I pressed all the turrets into the board. I know what the circuit is going to look like, so I finished, I did like a final layout. And this is what the circuit board is going to look like when it's all populated up. And went through a couple iterations moving things around. And it just fit on this board. I mean, just exactly the right number of turrets there. So even with some of the off-board wiring I'm going to do for like grid stopper resistors and screen resistors. So we got real lucky with the width of this board. It's just perfect. I do need to get a few parts. I found a lot of components that I can use, some pots, master volume pot, that dual gang pot there. And a lot of the passive components I have already. I do need to get some of the filter caps and things like that. So what I'll do is I'll put together maybe a list of things that I need to buy to complete this. I'll go ahead and purchase those. And then I think the next step, once that gets in, I'll have to start fabricating this chassis and then painting and labeling this front panel. And then from there, I need to populate the passive components on this turret board along with the flying leads. And then from there, it's just a matter of putting it all together and wiring it up. It takes about maybe about 12-13 hours of soldering, and then we can fire it up for the first time. But there's still a lot of work to do, so stick with me.